So, just as the name says, triangulation is a process of making measurement by creating a network of triangles. Okay, like this, maybe what we will do, we will create a network of triangles, and at these apex points of the triangles, we will have our control stations or survey stations. From here, we shall carry out all the measurement. Now, this will go along this way. Now, this will have some angle, this will have some angle, this will have some angle. There will be some sides. Let's say that this is A side, A point, this is B point, and this is C point. Let's say that this is not A, this is B. The side opposite to angle capital B is small b. Then similarly, this is side A, this is side C. Now we have a rule, okay, sine rule, that A by sine of A is equal to small b by sine of B is equal to C by sine of C, this way. So this is our sine rule. Now, if we measure only one side and all the angles, we can measure the other two sides. Say, for example, we have measured this B line and we have measured the angle A, B, and C. Therefore, to find out what will be the side A, from this formula, we want to find out A. We know B, we know A, we know capital B. So very easy, right? We want to find out small a. So it is going to be small b multiplied by sine of capital A divided by sine of capital B. So this is the basic principle of triangulation. What we are doing here, we are measuring all the angles and we are only measuring the first line, okay, or one line, okay, here. So if we do that, we can find out what is the A side, what is the C side. Then we can increase the triangle in this way. Now we already know A side. In this new triangle, we know the A side. This side we already know from previous calculation. If we measure all the angles of the new triangle, then we can find out the remaining two sides, right? Then it moves ahead. Now we have another triangle here. In this new triangle, this side is already known. If we measure the angles, we can find out this side and this side. Okay, similarly, it will go ahead and again, we already know this side. If it goes this way, again, we already know this side. So this is the basic principle of triangulation. Here, we are measuring the angles. We are measuring all the angles and we are measuring one side at the beginning. The side that we are measuring will be called baseline. Okay, this is baseline, this one here. So this is baseline and we are measuring all the angles. Now, what should be the general shape and size of the triangles? Okay, now we saw that we are depending upon sine A and we are depending upon sine B. Like this, we are depending upon the sine of the angles. So it is like that. If the angles are very small or very large, we see that if there any error occurs, the propagation of error. Why? If we make errors or mistakes in the measurement of one angle, what will happen? The value of the sides will change, if the value of the sides are going to change in one case, then all these values are going to be wrong. Therefore, it is very important that we have correct values of angles. And therefore, it is recommended that we do not select very small or very high values of angles. Okay. Therefore, there is a term called well-conditioned triangle. Now, what is well-conditioned triangle? In a well-conditioned triangle, all the angles are either they are greater than 30 degree and they are also less than 120 degree. So this is the condition of a well-conditioned triangle. Okay, so this is the condition of a well-conditioned triangle. So for creating a network of triangulation, we require or we should be trying to establish well-conditioned triangle. Now, if the triangle is of small size, if we are doing our survey work in a very small area, then we can use this type of, now this formula, this sine rule. Okay, this is to be used in case of plane or 2D triangulation. Okay, if we go for a very large area where the surface of the earth is to be taken care of like this, if we go to a very large area, okay, then what may happen, the plane or 2D trigonometry may not be used. This is a separate case. This will be becoming geodetic triangulation. Okay, this will be becoming geodetic triangulation where the triangles will no longer be 2D triangles. It is going to be 3D triangles. So we are not studying about that. We are studying about only this, which is 2D triangulation. Okay, where we can use this formula and we can carry out our calculations. Now, before the discovery of EDM instruments, what is EDM? Electronic distance measurement. Electronic distance measurement equipments are like, for example, total station. There are some other equipments also, but one of the examples is a total station where we use electronic principles. We use electromagnetic wave to calculate the distances between points. Nowadays, we are going to do that only. But initially, for calculating accuracy, we used triangulation. Okay. So, so if we are asked about the drawback or disadvantage of triangulation, what is the main disadvantage of triangulation? We see that we create a triangle, we carry out our measurements here, and then we proceed, right, to the next triangle based on the calculations of the first triangle. Now, if we make a mistake somewhere in one of the angles, then what will happen? What will happen? All these values, these sides are going to be wrong. Then in the next triangle also, what will happen? The error is going to be there. All these sides, all the angles are going to be now wrong. Okay. And we should also see one point, since this is a triangle, so we can measure all the angles and we can have a check, right? If we add all the three angles, A plus B plus C, this should be 180 degree. So this is a kind of a check for the angles. We will come to know if we have measured the angles correctly or not, if their summation is 180 degree or not. If their summation of 180 degree, then okay, maybe we have calculated properly. But there is no such um, accuracy check for the length measurement, right? So therefore, we should have to be careful in this process in calculating the angles. The angles are correct, then only the sides are correct. Okay, so if we make error somewhere in measuring these angles, then the sides are going to be incorrect. All our data will be incorrect. So this is one of the main disadvantages of triangulation. Now, for what we use triangulation, we will use it for large works. We will use one of the base, one of the most common example is near water bodies, lakes or rivers. Around there, we can use triangulation survey to carry out our survey work. Now, what are different types of triangulation? Now, based on their accuracy, it has been divided into three parts. One is primary. In primary, what we do, our first order, primary or first order, we are going to do very accurate works. Okay. So large scale works, like you are preparing the map of a country, like you are finding out the crustal movement of the earth surface, this type of things we will do. Then secondary, number two is secondary, and number three is tertiary. So this is depending upon the accuracy of work. This is the most accurate, then this one, and then this one. So this one will be used where the accuracy is not that important, and this will be used in average accuracy requirements. Then, depending upon the shape of the network of triangles, there are different uh, classification. So if we are going along this way, okay, if this way we are going, then this is a single chain, okay, single chain of triangles. Then if we go for, say, for example, we have triangles here also, like this. Sorry, sorry. Okay, so I'm just saying that we have two rows. Okay, then that will be double chain of triangles. That way we have different shape of triangles. I'll just show you here. This is primary, secondary, tertiary. Okay. Okay, so this is double chain of triangles. This is central point figures. It can be of any shape. Ultimately, we are getting some triangles. It can be quadrilateral. We are making measurements here, but we have triangles only ultimately. Then this can be grid iron system. In grid iron system, what will happen? We are using two sets of equipments. First, we are dividing the area like this into grids, and we are carrying out measurements here like this somewhere. Okay, so all these measurements are taken carefully, and then the measurement inside this area will be taken with less precise instrument. Okay, that way, if it is done, this is grid iron type of triangulation. Okay, now this is derived, okay, derivation is there which we do not require. What is the best shape of triangles to give us correct values? Okay, an isosceles triangle with angle equal to 56 degree, 13 minutes, 40 seconds. If we can establish a triangle, a network of triangles where two sides are equal, two angles are equal, the value of these angles being 56 degree, 13 minute, and how much? 40 seconds. Okay. So if we can establish this value, that is going to be the best triangle that will give us the least amount of error, right? So, but of course, establishing a triangle like this is not going to be possible in the field because we have to look for suitable points. We have to see, okay, if these 2 points are visible or not, intervisible or not. We have to see, okay, this the ground is level or not. These type of many factors will be there in selecting these survey stations. Okay, so if we go to a terrain which is hilly, which is having a lot of obstructions, then it will depend upon suitable points, right? We cannot just select any point that we wish. We have to select points according to the suitability of carrying out the work. Therefore, establishing a triangle like this is not possible in the field, but we should try to establish more or less an equilateral triangle, say for example, or if not, then we should at least try for a well-conditioned triangle where all the angles are greater than 30 degree and less than 120 degree. That is the condition. If we keep it that way, our errors will be less. Now there is a term strength of figure. Now we do not need to know how to calculate the strength of figure. There are some formulas and calculations. It was there earlier in our syllabus. Now it is no more in the syllabus. Just the term strength of figure. Now when we are saying that we can go this way like this, we can create a network of triangles. That means we can go carry out the survey work in different ways. We can say, for example, we can take this as the baseline. First, we are measuring the length of this line. Then we are calculating these angles, right? Then we are going this line, this line, this line. Then maybe we can go this way also, or this way. So that way, or we can go measure this first, measure this, or if the network is further complicated, something like this. So what way we will carry out our survey work, okay? In which way we will go. That is the term related to strength of figure. So the strength of figure is directly related to the accuracy, okay? Directly related to accuracy. In whichever way our accuracy is higher, we should proceed that way. So to find out in which way our accuracy will be higher, we find the strength of figure. Then we will come to the point of intervisibility and height of station. If we are carrying out measurement between 2 points like this, now this part is important. We have, say for example, these three stations. Now, first we need to say, for example, measure the distance between these two, right? Now we have to measure the angle between this and this and this, this and this, and this and this. All these angles are to be measured. To do that, this point and this point has to be intervisible, right? We have to see from point A to point B. If they are not intervisible, at least we have to put some signals over there. Okay, the ranging rod that we use in the laboratory is the simplest form of signal. There can be other type of signals also. there can be a pole, there can be some light source on that pole. Like that, we can have different types of signals. So from point A, can we see point B? Can we see it directly? Or if we have to apply a signal, if we have to use a signal, if we have to use a signal, what should be the height of the signal? So that is part of this study. Now, this will be required even with some of the modern techniques. Okay, some of the electronic distance measuring equipments also, this intervisibility will be necessary. Why? Because we use a prism. We are here at point A, we are at point B. We have to measure the distance between point A and point B. We have to put a signal over here. We put a prism over here, right? So these must be visible from here. So even with some of the modern techniques, we will require the intervisibility. Now, how do we find the intervisibility and ascertain between these two? Okay. Now, this formula we have to find out the height of the objects. Okay. Now, say for example, this is the surface of the earth, not surface of the earth, I'm sorry. This is the data. Okay. This is the reference line. Okay. Then this is the height of one object. This is the height of one object or height of ground at a certain point, say for point A. This is the RL of point A. Now, if we have a vision from here, we can have a vision like this, straight line. We can have another vision like this, another straight line. If we have a vision like this, where it will touch. Now, this is called horizon, right? Now, what is this distance? This distance, we are terming this distance as D, okay? This is D. So we have a formula for that. H is equal to D squared by 2R, 1 minus 2M. What is R? R is the mean radius of Earth. What is M? Mean coefficient of refraction. Why we are using that? Because we know that this is air. Whenever the straight line will travel, straight line of sight, okay, travel through the air is in different layers. Okay, air has different layers. Towards the earth, the air is, thicker. Then when you go up, it is thinner, lighter. Now, the ray of light, I'm sorry, once more, I'll try. The ray of light actually isn't traveling this way. The ray of light is traveling this way. There is some refraction. Okay. Okay, like this. Like this, the ray of light is traveling through refraction. For that, we are using the coefficient of refraction here, 2m. There are different values for over land and over sea calculation. So if we use these values, m is 0.07, radius of Earth 6371, if we do that, we find a formula like this. Okay. Now this formula, the h is the elevation and d is the distance of the horizon. Now this formula is a little bit different in different books by different researchers, but almost same. So we will use either this value or this value, 0.6749, 0.6735, around it, 0.6734, around there, we will get one value. So both of these values are correct. Different books have given slightly different values. So if we know the elevation, what is the distance to the visible horizon? We can find out with this formula. H is equal to 0.06735 or 3 d squared, where d is the distance and h is the height here. Okay, d is the distance here. H will be in meter, d will be in kilometer. Now using this formula, we will find out is the stations intervisible or not. If they are not intervisible, how much should be the height of these signals? That numerical is going to be important. Other are theories and easy. We have discussed a little bit. Please go through the notes. The notes have already been uploaded in Moodle. If you cannot find there, tell me. I will forward it to the seer. Okay. So thank you for coming.